Hey everyone, and a super warm welcome to our unfiltereddose.com community joining us for another deep dive.
Great to be here.
Today we are diving headfirst into some really exciting news from way out there in the cosmos. Get this. Scientists might have just stumbled upon the strongest evidence ever for life beyond Earth.
Yeah, it's pretty big news.
All thanks to a discovery on this planet, K2-18b.
That's right. And for this deep dive, especially for you Unfiltered Dose listeners, we've gone through a bunch of the latest reports. We looked at Unfiltered Dose itself, of course, but also NASA, Discover Magazine, CBS News, trying to get the full picture.
So wading through all the science talk.
Exactly. Our mission today is basically to cut through the jargon, pull out the really important stuff, the aha moments, make sense of this amazing story without getting totally bogged down.
Love it. Okay, let's get straight into it then. What exactly did the James Webb Space Telescope spot that's causing all this buzz?
Okay, so the excitement is all centered on detecting two particular molecules, compounds, in the atmosphere of K2-18b.
They are dimethyl sulfide, DMS for short, and dimethyl disulfide, or DMDS.
Okay, DMS and DMDS. Now, for those of us maybe not up on our alien atmospheric chemistry, why is finding those two things potentially such a huge deal? What's special about them?
Well, here's the kicker. On Earth, these specific compounds, DMS and DMDS, they're pretty much exclusively produced by living things.
Exclusively.
Almost exclusively, yeah. Mainly things like tiny marine phytoplankton, algae in the ocean, and certain types of bacteria. Life makes this stuff here.
Wow. Okay, so finding these chemicals way out there on another world. It's kind of like finding fingerprints, isn't it? Fingerprints that strongly suggest life might be there.
That's precisely the implication. That's why this is so electrifying. The lead researcher, Dr. Niku Madhusudan, actually called this the strongest evidence yet for extraterrestrial life.
The strongest evidence yet. That's a bold statement.
It is. It really points to a potential milestone, maybe a turning point in how we understand, the cosmos and our place in it. Are we alone? This might be a huge clue.
Man, it really makes you stop and think, doesn't it? The idea that life isn't just here, that it could just pop up elsewhere. It's a total paradigm shift, potentially.
Absolutely.
So, okay, give us the background. To understand this potential life, what kind of planet are we talking about? K2-18b. Where is it? What's it like?
Right. Context is key. K2-18b is pretty far off, about 124 light years away, over the constellation Leo.
124 light years.
Okay. And it's a type of planet scientists are now calling a Hycean world, Hycean.
Hycean. Okay, that's a new one on me. Break that down. What does Hycean mean?
Sure. Think of it like this. A planet with a really thick atmosphere that's dominated by hydrogen.
Okay, hydrogen-rich air. Different.
Very different. And crucially, underneath that thick hydrogen atmosphere, there's a strong possibility of vast oceans. Liquid water oceans.
Ah, okay. Hydrogen and ocean. Hycean. Got it.
Exactly. That combination, the hydrogen-rich atmosphere and the potential for water, makes these Hycean worlds really prime targets now in the hunt for habitable places outside our solar system.
So, a potentially watery world, but with a completely different kind of sky than Earth. How does it stack up against our planet? Size-wise, environment-wise?
It's quite different. K2-18b is way bigger than Earth, about 8.6 times the mass.
Whoa.
And roughly 2.6 times the diameter. It's a hefty planet. It also orbits its star much quicker than we orbit the sun. Its year is only 33 Earth days long.
Okay, bigger, faster orbit. What about temperature? You mentioned habitable zone.
Yeah, interestingly, even though it's closer to its star than Earth is to the sun, because its star is a cooler red dwarf, the estimated surface temperatures are actually in a range where liquid water could exist. Somewhere between roughly, say, minus 20 degrees Celsius and maybe up to 40 degrees Celsius.
That temperature range. Parts of Earth are like that, even though the planet itself is so much bigger and different. Wild.
It is. And it's worth remembering, we already had hints this planet was interesting. Previous observations back in 2023, they'd already found methane and carbon dioxide in its atmosphere.
Oh, right. I remember that.
Yeah, that was actually the first time we detected carbon-based molecules in the atmosphere of an exoplanet sitting in its star's habitable zone. So K2-18b was already, high on the watch list.
Okay, so it was already a star player, and now finding DMS and DMDS potentially takes it to a whole new level. How did Webb actually do that? How can it sniff out specific molecules from 124 light years away?
It really showcases the incredible power of the James Webb Space Telescope. This specific discovery was made using its mid-infrared instrument, MIRI.
MIR, okay.
You can sort of think of MIRI as this incredibly sensitive eye that analyzes the starlight filtering through the atmosphere of K2-18b as the planet passes in front of its star.
Like a cosmic barcode scanner for atmosphere?
That's a great analogy, yeah. The light picks up the chemical fingerprints, the specific wavelengths absorbed or emitted by different gases. And MRI gives us this data with just, well, unprecedented detail, unprecedented spectral resolution.
So this super-sensitive space detector, what did it actually tell us, is floating around in K2-18b's air.
Well, the data confirm the atmosphere is dominated by hydrogen, which fits that Hycean world picture we talked about.
Right.
But then, alongside the water vapor, carbon dioxide and methane, the stuff we already suspected or knew was their MIR, also picked up these distinct signals matching DMS and DMDS.
Okay, so the signals are there, these potential biosignatures, but how sure are we? Is this a definite eureka alien life moment, or is there wiggle room?
Yeah. This is where the scientific caution kicks in, and it's really important. Right now, these findings have reached what scientists call a 3 sigma confidence level.
3 sigma. Okay, what does that mean in plain English?
Think of it like, well, it's statistically significant. It's unlikely to be just random noise, but it's not considered definitive proof. A 3 sigma result means there's roughly a 0.3% probability. So 3 chances in 1,000 that the signal they detected is just a fluke, maybe instrumental error or some random fluctuation.
Okay, 0.3% chance it's wrong. That sounds pretty low, but I guess in science you want to be really sure.
Exactly, especially for a claim as massive as finding signs of life. The gold standard in physics and many fields for discovery is 5 sigma.
5 sigma?
Yeah, 5 sigma means the chance of the result being a random fluke is incredibly tiny, about 0.000006%, or 1 in 1.7 million. Think Higgs boson discovery level certainty. That's the threshold they really aim for to say, okay, we've definitely found something.
Gotcha. So 3 sigma is exciting, very promising, maybe even probable, but not quite the slam dunk yet.
Precisely. We're not at that absolute certainty level. However, the researchers estimate that getting maybe another 16 to 24 hours of Webb observing time focused on K2-18b, that could potentially push the data towards that crucial 5 sigma confirmation.
Okay, so more observation time could nail it down. That sounds achievable. What about the amount of this stuff, the DMS and DMDS? Was it just a tiny whiff, or?
This is another really striking part of the finding. The estimated concentration of DMS, it seems to be over 10 parts per million K2-18b's atmosphere.
10 parts per million? How does that compare to Earth?
Well, here on Earth, where it's produced by plankton and bacteria, the concentration of DMS in our atmosphere is usually less than 1 part per billion.
Billion. Wait, so it's potentially thousands of times more concentrated on K2-18b than on Earth.
Potentially, yes. That's what the initial data suggests. It's a huge difference.
Wow. So if, and it's still an if, but if it is being produced by life, that concentration would imply what? A massive amount of biological activity, a really thriving biosphere.
You would certainly suggest the potential for very significant biological activity, yeah. Perhaps geological or atmospheric processes we don't fully understand yet, or maybe a biosphere operating at a scale or in a way that produces far more DMS than we see driving the cycle here on Earth.
It's intriguing.
Okay, this is all incredibly exciting, but like you said, caution is key in science. What are other experts saying? Is the whole community convinced already?
No, not convinced yet. The reaction is definitely a mix. There's palpable excitement for sure, but it's tempered with that healthy scientific skepticism you'd expect.
Makes sense. For instance, Dr. Mans Holmberg, who works with the Space Telescope Science Institute, described K2-18b's potential ocean as possibly deeper than any on Earth, which really highlights how alien this place might be. He stressed that we're looking at a system very different from our own.
So acknowledging the potential, but reminding us we're not dealing with Earth 2.0.
Exactly. And then you have others, like Dr. Stephen Schmidt from Johns Hopkins, taking a more conservative stance. He called the findings a hint, really emphasizing that we need much more evidence before jumping to conclusions about life.
A hint. Okay.
So the general feeling seems to be this cautious optimism. Everyone agrees it's fascinating, potentially groundbreaking, but the consensus is definitely, we need more data. Let's verify this.
Right. Extraordinary claims require extraordinary evidence, as they say. So let's dig into that skepticism. What are the alternative explanations? Could DMS and DMDS be created without life on a planet like K2-18b?
That's the critical question scientists are grappling with right now. It's theoretically possible that non-biological processes could produce these compounds.
Like what kind of processes?
Well, maybe complex photochemical reactions happening high in the atmosphere, driven by the light from the star. Or perhaps geological activity volcanoes, vents, things happening within the planet itself releasing these gases.
Mm.
We have examples of being cautious for good reason. Remember the excitement about methane detected on Mars?
Yeah, that was a big deal for a while.
Right. Initially, some thought it might be a sign of microbial life, but further evidence strongly suggests it's more likely from non-biological geological sources. So history tells us to be careful.
Okay, so just because life makes DMS here doesn't automatically mean only life can make it there. There might be weird alien chemistry or geology doing the job.
Precisely. And again, that 3 sigma statistical level, while good, isn't enough to completely rule out those other possibilities, or even just noise mimicking the signal. So researchers are now planning lab experiments to try and simulate K218b's conditions, the temperature, pressure, atmospheric mix, to see if they can make DMS and GMDS without life. And independent verification, maybe using different instruments or methods, would be hugely important.
And I imagine just reading these signals from so far away is incredibly difficult. Could there be a mistake in interpreting the light data itself? Like maybe one chemical signal looks confusingly like another's?
That is absolutely a concern, and one scientists are very aware of. Analyzing these exoplanet spectra is incredibly complex. You're looking for tiny dips in starlight caused by specific molecules, and sometimes the signals from different molecules can overlap or interfere with each other.
Ah.
There have been cases in the past with other exoplanet studies where initial detections were later retracted because it turned out signals were being misinterpreted. So there's a lot of work going into carefully vetting the data, making sure the DMS and DMDS signals are distinct and not being confused with something else.
Okay, so it sounds like a really meticulous, painstaking process, as it absolutely should be for something this big. But stepping back, even with all these necessary caveats, the potential implications, if this pans out, they're just enormous, aren't they?
Oh, absolutely enormous. Profound, really. If this detection is confirmed, if we establish that there's likely life on K218b, it fundamentally changes humanity's perspective on itself and its place in the universe.
How so?
Well, it would strongly challenge the idea that life is some incredibly rare, maybe unique fluke that only happened here on Earth. It would suggest that maybe the conditions for life aren't that hard to meet, that biology might be, well, a relatively common outcome in the cosmos.
It would totally shake up that Earth-centric view of biology, wouldn't it? The idea that we might not be the only game in town, biologically speaking.
Exactly. And you can already see how discoveries like this capture the public imagination. People are fascinated by this question. It also highlights how far our technology has come, that we can now build instruments like Webb, capable of detecting these incredibly subtle potential signs of life across such vast cosmic distances.
Yeah, it feels like we've moved beyond just philosophizing about it. We're actually gathering potential evidence. It's not just science fiction anymore.
It really isn't. We're developing the tools to potentially answer one of the biggest questions humanity has ever asked.
So speaking of tools and next steps, what happens now? What are the concrete plans to follow up on this hint?
Okay, the immediate priority is getting that follow-up observation time with Webb. Those observations are tentatively scheduled for late 2025.
Well, late 2025. Okay, not too far off.
The goal there is twofold. First, to try and confirm these DMS and DMDS signatures with higher confidence, hopefully reaching that 5 sigma level. And second, to gather more data to map out the planet's atmosphere in more detail, understand its composition and structure better.
Right, more time with Webb's amazing eye. What else?
Beyond just K218b, scientists will be doing comparative studies, looking at other known Hycean planets, comparing their atmospheres or their common features. Do any others show similar hints, building up a bigger picture?
Makes sense. Look for patterns.
And looking further ahead, there's the European Space Agency's Ariel mission. It's planned for launch around 2030 or so. Ariel is designed specifically to conduct large-scale surveys of many exoplanet atmospheres. You potentially find lots more candidates like K218b.
Wow, a dedicated atmosphere surveyor. Cool. And of course, this isn't the only way we're searching, right? We're still listening too.
Absolutely. The search for technosignature signals that might indicate intelligent technology using life continues. Projects like SETI, often involving citizen scientists analyzing vast amounts of radio telescope data, are still very much active. But this K218b discovery really underscores the shift towards searching for biosignatures, for direct chemical evidence of life, even if it's just microbial. The focus is increasingly on direct observation and evidence gathering.
It really feels like we might be approaching, well, something significant. I think Dr. Madhusudan used the phrase tipping point.
He did. He expressed this really hopeful view that perhaps This discovery, or discoveries like it enabled by Webb, could represent a tipping point. A point where humanity finally develops the capability to answer that fundamental question, are we alone?
A tipping point. That's a powerful way to think about it. It really feels like we're right on the edge of potentially knowing.
It's an incredibly exciting time in astronomy and astrobiology.
Okay, well, let's try and wrap this up for our unfiltered dose listeners. If you had to boil it down, what are the absolute key takeaways from this deep dive into K2-18b?
I'd say the main points are, when the James Webb Space Telescope has detected potential biosignatures, specifically DMS and DMDS in the atmosphere of the exoplanet K2-18b.
Chemicals strongly linked to life on Earth.
Exactly. 2. K2-18b is a Hycean world, about 124 light-years away, potentially having a hydrogen-rich atmosphere and water oceans, putting it in a habitable zone.
A very different but potentially habitable place.
3. While incredibly exciting, the detection is currently at a 3 sigma confidence level, which isn't definitive proof yet. Scientists are cautious and exploring non-biological explanations. More observations are needed.
Crucial caution.
And 4, if confirmed, this discovery would have absolutely profound implications for our understanding of life in the universe and our own place within it.
Couldn't agree more. And for you, our really engaged and curious listeners here at Unfiltered Dose, this is just...
Wow.
It's a genuinely significant moment unfolding in our exploration of the cosmos. It really speaks to that fundamental question about our place in the universe.
Absolutely. It highlights how dynamic this field is.
And the potential for even more mind-blowing discoveries just around the corner feels immense right now. This K2-18b story is a huge leap forward in what's proving to be an incredibly exciting scientific adventure.
And maybe a final thought for everyone listening. Just take a moment to consider, what would it truly mean if we confirmed even simple microbial life exists on another world? How would that confirmation reshape humanity's perspective on our own existence, our future, the nature of life itself?
That is definitely something to chew on. A profound question indeed.
It really is.
Well, thank you so much for breaking all that down for us. And thanks especially to our fantastic community at unfilterdose.com for joining us on this deep dive. Keep asking questions, keep exploring.
Thanks for having me.
We'll catch you next time.